just slightly less horrible than web UI. Don't do that. It's not a good idea. In some ways, better than Terraform. You cannot upgrade worker nodes. Bad. Click buttons. I think it's an excellent choice, actually. I will make two important assumptions here. First, you're using AWS. Second, you're using Kubernetes, or more specifically, Elastic Kubernetes Service, or EKS. Now, if I'm wrong about the first assumption, that's normal, because you might be using Azure or Google, and then this video might not be the best choice for you. If you're not using Kubernetes, then I don't know what you're doing. You must be. I mean, everybody is. So go ahead, switch to Kubernetes, right? This video is about how do we create, manage, destroy, handle, upgrade Kubernetes clusters in AWS. Which tools should we use and how should we use them? You could create and manage EKS cluster using AWS console or web UI. Don't do that. Don't even think about it. That's the worst idea, except if you're learning, if this is the first time you're starting to experience and to figure out AWS, maybe. Other than that, click is unacceptable. Don't do web UI. That means that you're not doing things that are reproducible. You don't know what you're doing. Others cannot review your code. Just don't click. Don't click. It needs to be as code, right? Or commands at least, something scriptable at least, right? The second option is for you to use AWS CLI. That's just slightly less horrible than web UI. Or maybe it's even more horrible. I don't know. AWS CLI, for EKS at least, is really, really bad option. And even AWS is not talking about it much. So don't. The second option also bad. You could use Terraform. Now, this is potentially the best option. Managing everything infrastructure related with Terraform is an exceptionally good option. Probably the best. But you might not want to do that either. Actually, it depends. If you're really proficient with everything AWS, if you understand how to represent some, I don't know, minimum 30 resources in Terraform, how to define them and all this stuff, it's a great option. It's probably the best option. But it's complex. AWS is complex. A lot of moving parts are around, and defining all that in Terraform can be a bit daunting. I mean, if you would be talking about Google Cloud or Azure, creating managed Kubernetes clusters over there, it's relatively easy, maybe one or two resources, maybe 20, 30 lines of Terraform. EKS in Terraform would need, let me stop there. Let me double check something. Just a second. Let's take a look at this Terraform definition. This is the shortest Terraform definition that I could find among those that I wrote before. It is the simplest possible EKS cluster definition that I have. So let's see how many lines of code is there. So that's 176 lines of Terraform definition required for the simplest possible EKS cluster. Now, there is a good reason to do that. Terraform is extremely powerful, it's extremely versatile, and generally speaking, it is a preferable way to do it. But if you want simplicity connected with AWS, that's not it. So there must be a simpler option to have configuration as code with EKS and without hundreds of lines for something relatively simple. And there is a better option, a simple option that is a good option, and that option is eksctl. Eksctl was initially created by Weaveworks. It is open source. Now it is adopted by AWS. They even converted it into their official, whatever the official means, CLI for EKS. Let's explore it. Let's see eksctl in 20 minutes or less. It's not gonna happen. It will not be 20 minutes. It will take more likely 30 minutes. And the reason why I know that is because in post-production, I realized how long does it take to go through eksctl and AWS and EKS and what's not. Think of it as being a mistake. 30 minutes, not 20. The only thing I did in advance, beyond having AWS account, is installation of eksctl CLI. So I have the CLI already downloaded and executable from my machine. Other than that, we're going to do everything together. So just go and install eksctl CLI and you can follow along. And by the way, all the commands are in a gist that is in the description of this video. So you can just copy paste the commands, right? You will need few environment variables so that your laptop, the CLI, knows how to connect to your AWS account. And those two are export AWS access key ID and set it to the value of your access key ID. Now, if you don't know how to, if you don't have access key ID and secret access key, you will need to go to AWS UI console and create the credentials for your user. Usually people, if you're using AWS, you should have those. If you're given an account by somebody, just ask them, your administrator. Anyway, get access key ID and paste the value into this variable instead of 3 dots as you see here. And you will also need to export AWS secret access key. And I will not show you what's the value either because I already created those variables. I don't trust you. Otherwise, if you would see it on my screen, you would be able to access my cluster. And I cannot let that happen. And the last one we will create is we will export kubeconfig to be whatever is the current directory and then kubeconfig.yaml. You don't have to do that. You actually don't have to create this environment variable. I just like to have kubeconfig in the working directory instead of the default one. And this also assumes that you have kubectl. Eh? If you're using Kubernetes, you don't have kubectl, then you're in a definitely wrong place. So I'm assuming you do have kubectl CLI. Okay, good to know. I was worried for a moment. And now we can start using eksctl, right? And let's say we could do eksctl create cluster. If I would press the enter key right now, it would ask me a couple of questions, I would answer them, and I would have a cluster in like 5 to 10 minutes. But we shouldn't do that because not everything should have default values. We might want to specify additional stuff with arguments instead of being asked questions. And that's much better. It's much better always to use arguments because then you can store the full command in some repo, in some documentation so that others can do exactly the same. And that could be, for example, the name of the cluster. It could be DevOps catalog, region where we want to run that cluster, let's say US East, which one? 1. And the version of Kubernetes you want to use, let's say 1.18 or I don't know, is 19 available? Maybe not. Anyways, node group, group name could be, for example, primary, and so on and so forth. Now, we're not going to do that either. Most people who use eksctl execute commands like this. And don't do that. It's not a good idea. Actually, it might be a good idea if you're creating a demo cluster and you just execute eksctl this and that. But if you're going to be serious, you want to create a configuration and then execute eksctl against that configuration, stored as a file, potentially living in one of your Git repositories, everything defined as code. Everything, code. We want to define infrastructure as code and not as random CLI commands. So if we could do that, if we manage to define our EKS cluster as code, then we would get to a similar result as using Terraform, but in a much simpler form. That's the goal. Let's see whether we can do that. I already created a configuration we can use, so let's check it out. And it's stored in a Git repository. So actually, let's clone that Git repo first. It might contain a couple of useful stuff we might want to use. So git clone https github.com. Oh, gitnub. No, gitnub not. github.com. My user is vfarsik. And it's called eksctl. What is the name? I forgot. Demo, yes. .git, right? The commands are in the gist. It's in the description. So I'm cloning the repository. I'm going to go into that repo. And let me show you a file. And that file is cluster 1.17. Let's say that we want to create a Kubernetes cluster based on Kubernetes 1.17. This is how the definition would look like. So instead of us specifying arguments, which we might easily forget and which we couldn't share easily with others and what's or not, we can define a cluster config, right? And that cluster config has some metadata, like this is the name of the cluster, this is the region, and this is the version of Kubernetes cluster. I'm running intentionally older version. You will see soon why. And then we have a group of managed nodes. It could be one or many. We could have many node groups, but in this case, one should be enough. I'm calling that one primary. The instance type, the size of VMs we want to use for the worker nodes of our cluster is going to be T2 small. Anything smaller than that, micro, nano, whatever they call it, is too small for Kubernetes. So T2 small, I believe, is the smallest workable node size in AWS. We should have a minimum of three nodes and a maximum of 6. Now, this minimum and maximum is pointless. Let me tell you, it's pointless as is. For that to work, we would need to set up a cluster autoscaler, which we might do later, depending on how much time I have. Anyway, and spot set to true. Yes, I want to use spot instances, meaning cheaper instances. Now you might be wondering, hey, how do I or how can you know about what do you specify there, right? Did I just type random values? I didn't. Of course, there is a schema, and we can consult that schema through eksctl.io documentation, and that one is this one over here. And we can see all the parameters of the arguments, everything that we can specify. It's not huge. I mean, considering that it's AWS and in AWS everything is huge, this is bearable amount of stuff we can specify. Some of them you might need, some of them not. Anyway, here are all the options you can use with EKS. Actually, now when I look at it, it is kind of huge. It is massive. But the good news, actually this is very good news, because that means that you have freedom to be very specific while still be going with a very simple solution if that's what you want, if that's what you need. And the simple solution is this one, the file that I'm showing you here. I'm specifying just the bare minimum, and then you can expand that to whatever you need. So now that we have a file, let's try again to execute eksctl CLI. So eksctl, and then we want to create a cluster just like before, but instead of specifying arguments, I'm going to specify config file, and the file will be cluster 1.17.yaml. So we will create a cluster or update existing cluster. We don't know. We're about to find out using the definition stored in that file. And there we go. Now it is creating all the resources, everything it needs. And there is actually quite a lot. Availability zones, subnets. Now it is then it started creating EKS cluster and the node group, and it will create CloudFormation stack. And this will take a while, right? So I will fast forward to the end of the process. It will be pointless for me to let you watch me watch this screen for like 5 to 10 minutes. So fast forwarding. Hey, while waiting for your cluster to be created, this is the perfect opportunity, the best possible you will ever have to subscribe to this channel. And I know that you haven't seen the whole video, but hey, click the like button if you already have a feeling that this might be a good one. If you don't think that's the case, then wait until the end and then click the like button. This is what happens when you're impatient and you wait for infinity. What is it, like 14 minutes, 13 minutes, 13, 14 minutes, and still we're halfway through or something like that. And then I start inventing silly things to say. I should go back to watching YouTube. Hey, it's finished. That's brilliant. Okay, so let's see what did we get, right? How much did it take? Like 17 minutes, give or take? Slow. Shame on you, AWS. This is not Any issue with eksctl, simply it takes a lot of time to create a cluster and all the related resources in AWS. What can you do? Okay, so we got the cluster. Let's, what should we do first? This is my AWS console, yours is as well. Make sure that you selected the region that you're using. I'm using US East 2. Actually, US East 1 is my preferable region, but there was not enough capacity there. So I switched to US East 2, and I can go to, let's say, EKS and Elastic Kubernetes Service, and I can see my cluster here in the list of clusters. It says update now. Don't do that. I already told you, don't click buttons. Use dashboards only to see what's going on, not to operate your cluster. Everything defined as code. Store it in some config files like what we're doing right now. I'm going to show you how to upgrade your cluster later. If you go to the search box and say cloud formation, we can see here cloud formation, and those are the cloud formation definitions, stacks that eksctl created for us, right? Those are all the events, all the resources. Those are the things that were created from one stack, and those are the things created from another, which is much shorter. What eksctl does for us is it creates stack files, cloud formation stack files, which are horribly complicated. So don't try to do it yourself. This is one of the big advantages that eksctl gives us. Let's go back to the terminal. And what did we get? eksctl, we can do something like get clusters in the region US East, I don't know how to type, ES2, was it, right? And then we can use eksctl to list all the clusters we have. I have only one. This is a demo one. We can also, it created the kubeconfig for us, right? So we can do something like kubectl get nodes. We can see all the nodes in a cluster. Ta-da-da! And you will notice that the version is 117. That's because simply that's the one we specified in the config file we used. We can do eksctl scale node group, and then type the name of the cluster, which is DevOps catalog, and specify how many nodes we want, like let's say 4, we have 3 right now, and the name of the node group, which is primary. We could do this, but do not do this. This is another important thing. Do not press the enter key by any chance, because you don't want to manage the size of your cluster like this. You want to install cluster autoscaler. And to install cluster autoscaler, unfortunately, eksctl does not provide the option to install cluster autoscaler, at least not today, which is January 2021, which is very unfortunate, because that means that you would need to go to and follow the instructions from AWS itself. And those instructions are, I will post the link in the description section. Those instructions are those. And look at this. You need to follow all this, create policies, create this, create that, and those are all the instructions how to create cluster autoscaler, which will scale your cluster automatically depending on the workload, which is definitely something you should do. But this documentation is horrifying. Horrifying, especially since knowing that Azure and Google, they all give you checkbox. And do you want cluster autoscaler? Yes, except EKS. Anyway, happy thoughts. So, but the summary of what I'm trying to say is that do not scale your cluster manually, like using eksctl scale node group. Do it automatically by following the instructions how to create cluster autoscaler. What we did so far, we enabled it. We have all the labels and everything in the cluster. You just need to follow instructions to create additional resources that you need for that. So scale it automatically, don't scale it manually yourself. Going back to, now let's go back to what else we can do. I'm going to cancel this command. We're not going to scale our cluster manually. Let's say that we have a task that we want to upgrade our cluster from running Kubernetes 1.17 to Kubernetes 1.18. How would we do that? And I already told you, do not go to the web UI and say, yes, I want to upgrade. Don't. Change the definition. You would go to the file that we defined and change it. Or, for simplicity reasons, I defined another file. And I'm going to show you what's the difference. So if we take a look at this is the file that we used to create a cluster initially. We would make changes like the ones I created in this file 1.18.yaml, and the changes are just change the version to 1.17, from 1.17 to 1.18, and here is the tricky part. And this is one of the things that really annoy me with EKS. It doesn't have rolling updates. We cannot upgrade the worker nodes of the cluster. The only thing we can do is create a new node group. So instead of primary, we're going to create a new node group called 118. The name can be anything except that it must be different. And that node group will be with the correct version of Kubernetes. So in other words, what I did here is that before, in the old definition, it was called primary, the node group. Now it's called primary dash something else, for a simple reason, because it needs to be new node group to run new version of Kubernetes on the worker nodes. Horrifying, horrible. But again, this is not the fault of eksctl. Actually, now when I think about it, it might be. eksctl could implement that logic internally. But anyways, the main culprit here is EKS. You cannot upgrade worker nodes. You must create a new node group. So to upgrade the cluster, summary, we change the version of the cluster, and it was 117 before, now it's 118, and we changed the name of the node group. Silly, I know. So now to upgrade it, we can do eksctl upgrade cluster, and then config file will be cluster 1.18, right? And we hit the enter key, and let's see what will happen. If you're familiar with Terraform, you probably know that the results. The outcome is that nothing happened. We are just seeing on the output the plan. So if we do continue with this, the version will change from 117 to 118. And this is informative. It is telling us what would happen if we would proceed with the process. So we do want to proceed, so we need to type approve as additional argument. So we're going to execute the same command, but with -- approve. And then it's going. And this will take a lot of time now because it needs to create a completely new set of nodes. So actually, one step back. It will need to upgrade the control plane. That's the managed control plane by AWS. And it will create a second node group that is based on the newer version of Kubernetes. And then we will see later what we have to do with the old node group, but we'll get there. For now, I'm going to fast forward to the end of this process. It will take a while. A lot of time, not a while. It will take a long time. I'm in a mood today. And then my mood goes terribly wrong when I need to wait, but that's life. Let me interrupt fast forward. This part is extremely annoying. I cannot explain how annoyed I am. And I know what you're thinking. You're thinking that I'm annoyed that it takes so long, and I am. I'm very annoyed that it's so slow. But what irritates me even more is that there is no status. I don't know what's going on. Is it blocked? Is it hanging? Is it progressing? We don't know. Or at least we cannot know by looking at the CLI. It would be great if it would provide some form of status. Hey, everything is okay. I'm upgrading the control plane, which is most likely what it's doing. I don't know. I cannot know what it's doing by looking at it. It may be some estimated time to... I don't know. Give me something that would give me hope that after 10 minutes of waiting or more, this is not just hanging indefinitely, but it's going to result in something useful. So the lack of information about the progress is horrible. You can get away with it if it takes a minute or two, but when it takes 10, 15, 20 minutes, or I stopped even counting time anymore, then it's very, very disappointingly annoying. Yeah, Okay, back to fast forward. Happy thoughts. Finished. Oh my, I cannot believe it's done. Okay, This actually didn't take that much longer, to be honest. Upgrading cluster is slow in all the vendors. Like it's slow it takes like 20, 15, 20, sometimes half an hour in Azure and Google. But are we finished with upgrading? That's the question. That's the real question we need to ask ourselves. Is this it? Single command to upgrade the cluster? Let's check it out. Kubectl get nodes. What are the nodes we have here in the cluster? Ta-da-da-da. Huh. No, not yet done. So what this command did, actually, I mean, I knew in advance. I'm just pretending that this is a dramatical effect. What that command did is it upgraded the cluster. And in AWS, in EKS terms, upgrading the cluster doesn't mean upgrading the cluster. It means upgrading the control plane. So the control plane of our cluster is upgraded. The nodes are not yet upgraded. We need to do that next. So we have our control plane upgraded. Let's see how we can upgrade the nodes, the worker nodes, right? Because they're still running 1.17. Control plane is 118. Hey, so we need to execute eksctl create node group that is specified in config file cluster 118. You remember how I showed you before in the config map that I changed the name of the node group. Now it will think that that node group doesn't exist and it will create it. Let's see. Oh, config, that's a wrong argument. Config file, u out. Okay, now it is creating a new node group. It is creating a node group based on Kubernetes 1.18. And you know what comes next? Fast forwarding, because this will take. So actually, no, before I fast forward, let me retrieve my steps. I said earlier that it's slow everywhere. It's slow. It takes 10, 15, 20, sometimes even 30 minutes in Azure and Google. But they upgrade your whole cluster, the nodes and the control plane and everything. This was very slow, considering that in all this time, and I did not measure how many minutes, but it was a lot, all we accomplished so far was to upgrade the control plane. Now, we are not even upgrading now the nodes. Remember, you cannot upgrade worker nodes. You cannot upgrade node group, at least not that I know. We are creating a new node group so that there will be new nodes based on 1.18. We're going to see later what we should do with the old nodes. That's coming later. For now, we're creating a second node group based on Kubernetes 1.18. Now fast forward. Okay, we got a new node group. So are we finished now with upgrading? Let's take a look. Kubectl get nodes. So what do we have now? We have 6 nodes. This is ridiculous. This is funny. Oh my god. Again, I cannot blame eksctl. This is how EKS works. Anyways, we can see that we have 6 nodes. And some of them are 1.17, some of them are 1.18. We still need to delete now the old group, right? So it is not doing rolling upgrades, which are standard. Basically, every single vendor is doing rolling upgrades, except EKS. So we need to create a new node group. We already did that. That's what we just finished doing. And now we need to delete the old node group, the one running 1.17. So how do we do that? eksctl delete node group, and the config file is, what is the config file? Cluster 1.18, and then only missing, right? So we are telling eksctl that we want to delete all the node groups that are not specified in that config file, because we changed the name. Through that, we created a new one, and now we're telling it, hey, delete everything that is left over from before. And there we go. So we got the plan, because whenever there is a destructive action or action that modifies the state of something, we need to confirm it with the same command, but then approve, right? And now we're deleting the node group, and it should hopefully not take long. I mean, just deleting stuff. It is not Actually, it might take a while because it needs to evict all the pods, and it might need to wait until the SIGTERM signal responses are coming from the pods, and so on and so forth. So let's see, it shouldn't take that much, so I will fast forward still. Oh, no, it's finished. No need to fast forward. Okay, excellent, excellent. The whole process is silly, but I'm not trying to convince you to go somewhere else away from EKS. This is a session about EKS. So what else? No, let's check the nodes. kubectl get nodes, and now we have almost 3 nodes, right? So the old nodes, those based on 117, are being deleted. Now scheduling is disabled, and they will be gone a few minutes later. You need to trust me. It takes time because really the previous command did not terminate the whole process, just send a signal, hey, delete it, and deletion is now going on. Okay, what else can we do? There is utilities. We can install some add-ons. Let's see which add-ons we have. So it's going to be eksctl utils. We want to describe add-on versions for the cluster. Oh, not cluster, DevOps catalog in the region US East 2. And then these are the add-ons we can use. Now, unfortunately, at this moment, the only add-on, there is one add-on only, which is VPC CNI. We might be able to extend it with our own. We could write our own. But anyway, not many add-ons, not much more we can do. The last thing we're going to do, right, is to destroy everything we did. And then we're going to talk about what we experienced and what's not. So destroying the cluster EKS cattle, we want to delete the cluster defined in config file cluster 1.18, and we want to wait until that is finished. And this means, you guessed right, fast forward. Actually, not fast forward. I'm going to leave this running in the background. Let's go to the other screen and have a quick chat about EKS and EKS cattle and what's not. So that was EKS cattle. Is that the way how you should manage your EKS clusters in AWS? Maybe. Yes, most likely. I'm not sure. That's a confusing answer, isn't it? So what I'm really trying to say is that it is definitely one of the 2 recommended or best ways to manage your cluster. Now, the second one would be Terraform. I'm going to skip explaining why doing it from web UI or console is bad, why AWS CLI is really horrible, why Chef and Puppet are out of the game anymore, and so on and so forth. So it's really down to Terraform and eksctl. Which one I prefer? Now, if eksctl would be only command line that doesn't have a config file, I would say without doubt, it's not worth it. You cannot store it in Git, you cannot do version control, you cannot do reviews and so on and so forth. Go with Terraform. But since eksctl allows us to specify those config files with YAML that defines everything we need to have, it's actually in some ways better than Terraform. Now let me explain what in some ways that means. Terraform is still more versatile, right? It manages everything, including EKS. So from that perspective, Terraform is much better. Now, the problem with Terraform, and specifically related to EKS, is that you need a lot of things. You need to define a lot of resources. There's a lot. It's not just, hey, I want EKS cluster. No. It's a lot of resources are involved in enabling EKS cluster to work. And as you saw before at the very beginning, we're talking about hundreds of lines of Terraform HCL configuration for something that is not any better than what we just did in like 20 lines. So eksctl is simpler. It's straightforward. It abstracts the things that are just silly, that are not necessary for many people. So I would say if you're looking for, if simplicity is important without sacrificing a lot, at least, the versatility and an ability to do things that you need, I would say eksctl is a better option than Terraform. So if you want simple, if you don't want to lose your hair over trying to figure out everything you need for creating and managing and upgrading and what's not an EKS cluster, go with eksctl. Now, if you're a power user, if you really understand AWS, then Terraform still might be a better option. And there is actually another thing you might want to have in consideration. If EKS, if Kubernetes is only a fraction of what you have in AWS, then definitely Terraform. But if you're mostly running your stuff in Kubernetes, if the main workload, the majority of the workload is in Kubernetes, then yes, eksctl is a good choice. I think it's an excellent choice, actually. So go with it. Try it out. Let me know what you think. And what else? Yes, subscribe to the channel, hit the like button, you know, all that stuff. Buy the books. I don't know, maybe I should do commercial ad. Marketing is not my thing. And see you next time. Cheers.